right, today, this is the last thing we are learning. Okay, so this is trigonometric substitution. Now the hardest part is you guys have to like memorize this, but I'm gonna give you this on the quiz. So I made the quiz this morning. There's 4 L'Hopital's rule. There's 2 partial fractions, and I'm gonna have 2 of these on the quiz.
Is this what BC does?
Is it like a 3-page?
BC does partial fractions and trig substitution.
Is it a 3-page quiz? 4-page?
3 quizzes, 3 pages, because you need a room, because there's quite a bit of work, right? Partial fractions and trig substitution takes quite a bit also. So these are the substitutions. So see, the thing is, when you go to college and you're faced with an integral, what do? Well, the first thing you ask yourself, is it on the list? If it's on the list, then you can write down the answer, right? Second thing, can I do a U substitution? Next thing you ask yourself, can I do integration by parts or tabular? And then what if you can't do any of those? Then we try these other things. Partial fractions and trig substitution. These are kind of like last resort kind of things that you want to do. And in fact, there's a Z substitution thing, but we're not going to even touch that. So when should you want me to do one of the problems for you?
Sure.
You know what? I'll do number 1 for you then. Because number 1, if you look at number 1, here's number 1, dx over 1 minus x squared. Now, on the thing it says compare with problem 1c on partial fractions, because this problem, you can do partial fractions, right?
Yeah.
Because you can factor the denominator. Look, if you factor the denominator, right? You actually did this problem on last night's homework. You can do partial fractions because you can go 1 over 1 plus x times 1 minus x is equal to a over 1 plus x plus b over 1 minus x. So you can do partial fractions, but you can also do a trig substitution. So if you have a choice, which one is easier? I would say partial fractions is a little bit easier. But on the quiz, it's going to say use partial fractions to do these 2 problems, and then use trig substitution to do these 2 problems. So you're going to have to do it whichever way I tell you, if you want the full point. So what are the trig substitutions, Mr. Park? Well, if you see a squared plus x squared, your substitution will be x equal a tangent theta. If you see the expression a squared minus x squared, then your substitution will be x equals a sine theta. And then if you see x squared minus a squared, your substitution will be x equal a secant theta. I will give you these formulas on the quiz so you don't have to memorize them. Okay, so the directions for the last 2 problems say use trig substitution to do these problems, and then I'll give you those formulas right there. So look at this right here. This is the a squared. So which one am I doing? 1, 2, or 3?
2.
A squared minus x squared. So that's this one. So we're going to use this one. So that means if this is a squared, that means a is 1, right?
Yeah.
Like if this was a 4, then what would a be?
2.
It would be 2. If this was a 9, then it would be a 3. You guys see how this works? So your substitution will be x equals 1 sine theta. Now you're going to ask yourself, why are we doing this? Well, you'll find out after we do the substitution. You'll see why we do this. Because of trig identities, that's why. So if x equals this, then what is dx? Which is the derivative. Cosine theta d theta. Now remember, you're actually computing dx d theta. We're just moving the d theta to the other side, just kind of like U substitution. Yeah? So what you do is you take these 2 things and you plug it into this. And hopefully the new integral we get will be easier than this. Well, we'll find out. So what do I substitute for this dx here? Right there. Cosine theta d theta. Okay, what do I substitute for 1 minus x squared? Well, if x is sine theta, what is x squared? Sine squared theta. trig substitution correctly, then A, use some by.
Cosine.
That's cosine squared, that's right. See, so whenever you do these trig substitutions, what's gonna pop out is an identity is gonna pop out. And then what is, can I do any canceling?
Yeah.
Yeah, this cosine cancels into one of those, and what is 1 over cosine? Secant theta, that's right. And is that on our list? Yeah, that's on our list. You guys remember, what is the integral of secant theta? Natural log, absolute value of secant theta plus tangent theta, and don't forget to put the plus c. All right, Mr. Park, I got full credit then. So if this problem is worth 6 points, I got 6 points. No. You got 4 maybe. Because if the original problem is in terms of x, your answer should also be in terms of x. Just like when you do a u substitution, don't you have to substitute back in? Same thing, so we make a trig substitution with thetas, we gotta resubstitute. So, how do I do that, Mr. Park? Because it says sine theta is x, but I don't even see sine theta here. So what do you do?
Nothing.
No, you do something, you draw the triangle. So doesn't that mean sine theta is like x over 1? You can draw a triangle for that, see? So you draw a right triangle, here's theta. What is sine? SOHCAHTOA. Opposite over hypotenuse. So sine theta is opposite over hypotenuse. So opposite over hypotenuse, x over 1. Use the Pythagorean theorem. What would this be? Square root of? 1 minus x squared. Now, it's easy. Natural log, absolute value. What is secant theta? Well, cosine is adjacent over hypotenuse, so what would be secant? Hypotenuse over adjacent. Plus, tangent theta is opposite over adjacent. Opposite over adjacent. And then don't forget to put the plus c. And, you know, where AB, I would accept that as an answer. However, this problem was the same problem we had on partial fractions, and I want to go back to it, because it says compare. That's why I'm doing it, because I'm not sure if some of you would even compare it. So compare, what problem was that? That was problem 1C. So what is the answer for problem 1C? Let's write that down. So when you did it the partial fractions way, this is the answer you got. It came out to 1/2 natural log absolute value 1 plus x minus 1/2 natural log absolute value 1 minus x plus c. That doesn't look the same, Mr. Park. It is the same. And if you look at my written solutions, I put it on the Google folder. I showed you how to go from here to here. And let's just do it for funsies, since I'm doing one of the homework problems for you anyway. How can I make this look like that? Now, like I said, on tomorrow's quiz, or Thursday's quiz, you can, once you have this is good enough. You don't have to simplify it to that. Just, this is good, okay? So the first thing I would do is make a least common denominator. At least that you can do, right? Okay. Mr. Park, you kind of, no, I don't know, Mr. Park, how you gonna get that? Well, let's go over here. Okay. So you got natural log. Now, isn't isn't 1 plus x the same thing as square root 1 plus x times square root 1 plus x? Isn't that the same thing as 1 plus x? Well, who's gonna even think of doing that, right? And then isn't this the same thing as square root of 1 plus x times square root 1 minus x? Right? Because when you multiply them, you get 1 minus x squared, right? And the reason you would do that is because, hey, these cancel out. Don't forget to put the plus c there. And so now you got, this is what you have now. Root 1 plus x over root 1 minus x plus c. Hey, it's kind of looking like it now. Now, using your properties of logarithms, what? So it's natural log, absolute value, 1 plus x, minus natural log, absolute value, root 1 minus x plus c. And then when you have a square root, isn't that like 1/2 power? So you can put the 1/2 in the front. Same thing here, this square root is like 1/2 power, so you can put the 1/2 in the front, and then is that the same answer? Yep, and there you go. But like I said, you don't need to do that, just, you get to hear it good enough. But that's why, but just be aware, when you go to college next year, you're gonna be doing these problems, and then, let's say you do partial fractions, you get this answer, but then if you do trig substitution, you get this answer, you gotta go, oh, am I correct? That's when you gotta know your properties of logarithms. Okay, now I wanna do one more example where there's limits on it, so, should I do one more of your homework problems? Is that gonna help you, or do you want me to make up one? Cause I think you need to practice. Okay, I'll make one that looks similar then. Which one looks good?
3, 2, 6.
2, I think looks good. Okay, I'm gonna erase. Everybody got it? Okay. Anyway, I did you got the complete solution. This is number 1. Okay, I'll make a problem very similar to problem number 2 then. Integral dx square root, and it has 9 plus x squared. Let's go 16 plus x squared. And then let's go from, instead of 0 to 3, let's go 0 to 4. Okay, now, see, when you're in college and then you're faced with an integral on AP exam 2, is it on the list? No, that's not on the list. Can I do U substitution? If I had an x up here, I could do U substitution, but no, can I do integration by parts? That doesn't look like something you can do integration by parts. So then you gotta ask yourself, can I do a trig substitution, or, well, can you do partial fractions with this? Because of the square root, you cannot do partial fractions. You have to be able to factor it, and you can't have square roots here. So you have to do a trig substitution for this one. So which one does this look like? 1, 2, or 3?
1.
1, because that's the one with the plus sign, right?
Sure.
So this is a squared. So if 16 is a squared, that means a is 4. So your trig substitution is x equal 4 tangent theta. And again, you're going to be asking, why do you do it? Well, after you substitute in, you'll see why. So if x equals this, what is dx? The derivative. 4 secant squared theta d theta. Don't forget, this is actually dx over d theta. We're just multiplying it on that side, yeah? Take these two things, and you got to take both of them now, because you have to substitute for everything now. Plug it in. Okay, so what do I plug in for dx? Right here. 4 secant squared theta d theta. Square root 16 plus x squared. Well, if this is x, what is x squared? 16 tangent squared theta. Now, some of you might be seeing something there, yeah? Not yet? Now remember, when you make a U substitution, the limits change, right? So if you make a trig substitution, the limits are also going to change. So you need to change these limits. Do not put 0 to 4. So how do you get the new limits, Mr. Park? Well, remember, this is from x equals 0 to x equals 4. So if I plug in 0 for x here, can I compute what theta is?
0.
Well, if you divide by 4, if this is 0, divide by 4, that's 0. Tangent theta equals 0. 0, that's right. And then what happens when I plug in 4 here?
1.
Well, if you divide by 4, you get 1. Tangent theta equals 1. Pi over 4. That's how you change the limits. Don't worry, I'm going to make it so it comes on angles that you know, right? Pi over 6, pi over 2, pi over 3, like that. Okay, and then look inside the radical. Hey, I can factor out a 16, and you get 1 plus tangent squared theta. Hey, you somebody. That's an identity. So if you pick the right trig substitution, what you're going to get is you're going to get a Pythagorean identity. That's what you're going to get. So this is like 16 secant squared theta. Okay, so let's see what we got so far. We got the integral from 0 to pi over 4 of 4 secant squared theta d theta over, what is the square root of 16? 4, which is good. It's going to cancel out that 4. And then what is the square root of secant squared theta? And don't say secant theta.
Absolute value.
Absolute value, see? Is it good? You're getting good. But between 0 and pi over 4, secant is positive, so we don't need the absolute value. Just like that. But you gotta know why we don't need it. It's because on those limits, it's positive. And then look, so many things cancel out. This cancels this cancels one of those, so basically you just got this. Secant theta d theta. Is that on our list? Yep. Don't worry, I'm gonna make it on our list. So, this is the same one we just had. Natural log, absolute value of secant theta plus tangent theta. This one seems to come up quite a bit when you do trig substitution. 0 to pi over 4, plug in the top number. Natural log, what is secant of pi? Here's the hard part for some of us.
Root 2.
Root 2 plus tangent of pi over 4. 1. Minus, now plug in the bottom number. Secant 0. 1. Tangent 0. 0. Where did that absolute value go? Well, root 2 plus 1 is a positive number, so we don't need the absolute value, right? Same thing, 1 plus 0 is positive, you don't need it. If you want to put it, you can though. And again, what is natural log 1? You need to know this on the AP exam. Natural log 1 is 0, so your final answer is natural log root 2 plus 1. That's your final answer. Hey, Mr. Park, how come the first problem we had to draw a triangle? How come we didn't have to draw a triangle for this one?
Definite.
Because it had limits. It's a definite integral. Because when you have a definite integral, you change the limits, and then you gotta plug in the top, so you don't have to go back to the x's, because you're changing the limits. Whereas if you don't have limits, if it's an indefinite integral, then your final answer has to be in terms of x. So that's why you gotta draw the triangle. So you know already, right? One problem is gonna be, you're gonna have to draw the triangle. The other problem is gonna be a definite integral where you don't have to draw the triangle. Question?
Can you go over the triangle again? Like how do you make it?
Okay, the triangle comes from your original substitution. So like, if you didn't have limits on this one, isn't this the same thing as saying tangent theta equals x over 4? This thing right here? Draw a triangle, just like trig class. You go like this. Here's theta. Tangent is opposite over adjacent. And then use the Pythagorean theorem, so that would be x squared plus 6b. That's how you draw the triangle from your initial substitution. But again, if there's limits on the integral, you don't have to draw the triangle because you're changing the limits. All right, so you only got 5 problems for homework. I think the last one was a little involved, but I don't know, I kind of forget. All right, so I'm gonna give you the rest of the time so you can do it because there's no buffer, right? Next class is the quiz already, so you gotta learn how to do this, right? So you have the complete solutions, follow that if you need to, otherwise I'm sitting right there.